Okay, let's solve this differential equation to see how we need to integrate. Here y prime is the derivative of y with respect to x. So let's write it as x dy over dx plus y equals to y squared. Now let's multiply dx to the both sides. So x dy dx goes by this, plus y dx would be y squared dx. Okay, now let's subtract this from the both sides. So on the left we're going to have x dy equal to minus y dx, which equals to y squared minus y the whole thing dx. Now they both got dx. Okay, so x dy equals to this, and now let's divide this by this. Also the right side. So this x goes by this, and this goes by this, and we're going to have dy over y squared minus y equals to dx over x over x. Okay, which itself equals to, let me write it, equals to 1 over y squared minus y dy, and this 1 over x dx. Now let's integrate the both sides. Okay, and the left integral equals to ln absolute value of y over y minus 1, of course, plus c, and this integral ln absolute value of x plus c, and ln is just logarithm which bases the Napier number. I talk about it more in the next videos. And let's show it as c prime, for instance. So let's subtract this from the both sides, and we're going to have this plus minus c, and let's write c prime minus c as c1. So by doing the integrations, we turned our differential equation into an algebraic equation, and let's solve it. Ln of this equals to ln of this, So it means that this equals to e to the ln this plus c1, and e is the Napier number, okay, and it equals to, and we can write it as this times e to the c1, and e to the ln of this equals to absolute value of x. We can, this goes here and e goes here, so ln of e equals to 1. Okay, and let's write it better. It is e to the c1 times this. Now this would be plus or minus e to the c1, and let's show e to the c1 is just a constant. Let's show it by k this, and let's solve it for y. Let's multiply into this, so y would be plus or minus k y minus 1, which equals to y minus and plus this. Now let's subtract this from the both sides. It is equal to y, okay, and let's subtract this from the both sides, so minus and plus this equals to y minus plus k xy, and let me and they both got y, so we have space here, 1 minus plus k this, and this equals to this, so from here y would be minus plus k over this, k absolute value of x over 1 minus plus k absolute value of x. And you know, here y actually is a function, and not just one function, one single function, and this minus and plus it doesn't mean that for every value of x y got two values, okay. There are two groups of solutions, one with the minus sign, minus this, and one with the plus sign, 1 plus this, and k is any constant also, of course. So that's it. Thanks for watching.